Alright, so in this section we're going to look at locus represented by the half line, okay, involving inequalities. So as we have seen before in the circle and the perpendicular bisector, when we have inequalities, there are certain regions that we actually need to focus on. So so similarly for the half line, okay, any of the equations involving inequalities, we need to focus on some regions which actually represent the variable complex number z. Alright, so let's look at example 34a. Alright, so first and foremost, please go ahead and write the expression in the form of the standard form, which is in this case what you see here. Right. So z again is represented by the point P, and 0 minus 2i is represented by the point A. Right. So what we need to do again, mark out the point A first. Alright, as you can see that I'm using freehand and my lines are all not straight. So for your case, when you present your answers, please make sure you use compass and rulers. Right, so the point A is actually here. So this is the point A at -2. You draw the horizontal dotted line. Right. Now in this case, it says, alright, if we look at the analogy of the vectors, alright, so we're looking at the argument of maybe the vector AP. Alright, so that means the angle that AP makes with the horizontal in this inequality states that that angle is actually between pi over 6 and 0. So what I need to do is just draw these two lines. Right, this line here representing the theta equals to 0, and this line here representing the angle theta equals to pi over 6. Right, so whatever which is in between, that will actually represent the complex number z, okay, such that it satisfies that inequality. So is this true or not? So let us maybe pick a point. So let's say if I pick a point P here, right, and I know that point A is there, so let's just connect the two. Alright. Now the argument that the angle that the vector makes, the AP makes with the horizontal, is this angle. Alright. Now is it obvious to you that this angle is actually outside the angle defined in the inequality? Yes, so you wouldn't want to choose that area, that region, to represent the points that represent the complex number z. Right, so that's why we shade the region in between the two lines that I've drawn here in red. Okay, as a further example, let's look at example B. Alright, so we will need to rewrite this in the standard form again, which quickly can be written as argument of now in example A, you see that inequalities involve less than and equals to, so they are not strict inequalities. But in part B, on the left side is strictly less than, whereas on the right side is less than or equals to. So there's a difference. Alright, so let's mark out the point P representing Z and the point A representing the fixed complex number 1 plus 3i. Okay, so again you have the imaginary excuse me, the real. Right, so let's mark out the point 1, 2, 3, and so this is the point A. Yeah, 1, 3, and then from there we do the horizontal, and make sure you put a circle at A, because like I said before, it does not include the point A itself. Right, so if we look at the analogy of the vector AP, So we're looking at the vector AP making an angle which is between pi over 3 to the horizontal and negative pi over 3 from the horizontal. Yeah. Alright, so let's draw the lines. Alright. And the region that we are interested to actually focus on, alright, that represent this inequality is everything in between here, alright, including the line at the angle pi over 3, but not including the line at the angle negative at the argument negative pi over 3, right? Okay, let's proceed with example 3. Okay, let's proceed with example 34C. Right, so in example 34C, you are given this. Alright, now again, this is not in the standard form, so we rewrite it in the standard form, okay, which is argument of z minus 2I less than pi over 6. Right, but in this case it is special because it seems that part C is similar to part A. However, alright, because there is no lower part of the inequality as in part A, alright, due to the fact that argument of complex number in the standard form must always lie in the principal range, and the principal range is actually this one, right? So therefore, alright, the actual half line, okay, must only extend all the way until negative 5 excluding negative pi. Okay, that is why we include negative pi here, because of the principal range of the argument. Right, so again, now let's put in the points. Okay, z is represented by the point P, and 2I is represented by the point A. Alright, so if we look at the analogy of the vector, alright, so you are looking at the vector AP making an angle pi over 6 from the horizontal and negative pi from the positive horizontal. Right, so let's mark out the point A first. You will have the imaginary, you will have the real. Negative 2 is here, right? So that is your point A. Right, so put a circle, the horizontal, and you draw a full line because it's less than or equals to, and you know that this angle is pi over 6. But now your vector AP must make an angle which is from pi over 6 from the positive horizontal all the way to negative pi. And where is negative pi? And it's not including, so you will extend. Alright, so the region required is actually everything inside here. Alright, so that will give you the region required in this question. Now in part D, it is a little bit more challenging, just a little bit. Alright, So again, in this question, it's not given in the standard form. Alright, you realize that the coefficient of z is 2i. Right, so we try to get the 2i out. Okay, so if you get the 2i out, then implementing the properties of the argument, you will be able to reduce, alright, the inequality into this standard form. Okay, now as in previous part C, there is no lower bound. In this case, there is no upper bound. Right, but we know that the upper bound for the principal range of argument is pi. Right, so let's see how we can actually denote the area wanted in this inequality. So we have successfully written it in the standard form. Right, so let's mark out the points first. Okay, so imaginary, real, alright, and 1 is 1.5. Right, so this point is the point A. Let me rewrite it for you again. Here is point represented by point P, represented by point A. Alright, so if you again look at the analogy of the vector, you're looking at what the vector AP makes with the horizontal, and the right side it tells you angle pi, and on the left, right, strictly bigger than pi over 6. Okay, so you draw the horizontal first from the point A. This is a point A, which is 1/2. Alright, so from here it must be less than or equals to pi. Alright, so it actually extends from the upper bound, and the lower bound for this case is pi over 6, which is this. Because it says strictly bigger than, you draw a dotted line, and you know that this, alright, angle is pi over 6. Right, so the region that you're interested in is actually this region. Okay. Alright, so to test whether you have shaded the correct point, it's actually quite easy. Just need to pick a point and see whether the vector joining the point and the point A is within the angle specified, the inequality.